Good day, everyone. Welcome to this webinar on peer and ERPs anywhere. It is great to see many participants from actually different parts of the world. We are broadcasting partially from Munich, Germany, partially from the US. Just a quick a few words before starting. Of course, the focus of this webinar is peer, and for the ones that do not know what the acronym stands for, it's Portable EEG ERP Researcher. Peer is an iOS application developed by Brainwave Software that allows you to measure ERPs virtually anywhere. Now, my name is Eduardo, and I work at Brain Products. Brain Products is the manufacturer of X.on, a wireless EEG headset, which is, as we're going to see shortly, a great peer for peer. I'm the moderator of today's webinar, and it is a pleasure for me to introduce you to today's speaker, Professor Olav Krigolson. And well, I don't think Professor Krigolson actually requires an introduction, but just a few words about his profile. He's the principal investigator at the Theoretical and Applied Neuroscience Laboratory at the University of Victoria in Canada. He's a leading expert in mobile EEG and real-world neurocognitive research. His work has been instrumental in pushing EEG beyond the lab into applied naturalistic environments. And then, academic achievements aside, Professor Krigolson is also the host of a beloved podcast, That Neuroscience Guy, and unsurprisingly, also one of the fathers of peer itself. So before handing over to our speaker, I would like to point out a couple of quick housekeeping notes, which were displayed on the loop before we started broadcasting. So the webinar is being recorded and will be replayed, and the replay will be shared afterwards on YouTube. Your microphones will be muted, but you can submit questions at any time using the question tab, the little icon with the little question mark on the top right of the control panel. And I will try to address them throughout the webinar, but I will save some of the particularly interesting one, which could benefit the rest of the audience, for the Q&A session at the end of the presentation. The presentation is meant, targets like a duration of about 45 minutes. So with that, it's my pleasure to hand over to Professor Krigolson. Please.
Thanks, Eduardo. I'll just get sharing going here.
Mm-hmm.
And hop over to, okay. So hopefully you can see the peer logo and the ERPs anywhere. Eduardo, can you just confirm that you can see it?
Yes, the presentation is being shared. Oh, good. Thank you.
Perfect. All right, let's go. Well, thanks for showing up, everybody. My name is Olav Krigolson. I'm a neuroscientist at the University of Victoria. And I want to tell you about peer and what peer is. So I'm assuming everyone in the audience is familiar with EEG, and for most of us, this is what EEG looks like. You have someone, with a lot of electrodes on their head, 32, 64, possibly even more, and they're connected to an amplifier, and that allows you to see the human electroencephalogram. All right, or EEG, and we use that to study a wide range of cognitive phenomena. All right, I'm assuming a lot of you also know that you can take this a step further, and you can do ERPs, or event-related brain potentials. And once you get into that space, you're still recording EEG from a cap to a recording computer. But typically you have people doing some kind of a task. So there's a stimulus presentation, and it can be an image, it can be a sound, it can be a video clip. But the whole idea is that when the brain sees something, so if something appears on the screen or you hear that sound, then you mark the data so you can go back and you can look at it and say, well, what was the brain's response to this very specific event? And this is how most of us do ERP research. I have a couple of ACT champs in my own lab, And we do this quite a bit of time. This is how we run our ERP studies, is with this kind of traditional setup, the two computers that are wired together. What's changed in the last, it's been over a decade now, but what's changed is that EEG has gone mobile. All right. So you get things like the X.on. So if you're not familiar with the Brain Products X.on, they have an excellent webinar about the X.on itself and how it works. But this is a fully functional EEG system. It's got 7 channels. It's easy to put on, and you can do EEG now with something like this, as opposed to having someone wired to a 32 or 64 channel system in a computer. So it allows you to be portable, mobile, if you will. You can go out in the world, because with a setup like this, you can basically go anywhere. Myself, I've collected EEG data at Everest Base Camp, the NASA Mars habitat, at sporting events and shopping malls, because you can actually go out in the world with this kind of technology. Now, where Peer comes in, what Peer is if you want to be truly mobile, then you don't want to be tied to a computer, right? You don't want to be dragging around a desktop or a laptop. You want to be able to do an EEG study off of an iPhone or an iPad, and literally ERPs anywhere. So just to give you a feel for what this looks like, I've got one of my grad students to make a short video that will introduce you to the idea of Peer and just how easy it is to use. And then what I'm going to do for the rest of the presentation is I'm going to take you through what is in Peer itself, some of the mechanics of Peer, and then at the end, I'm going to go through some of the research that's been done with Peer, just to give you a feel for what's possible. So without further ado, this is my PhD student, Matthew. You're going to see him put on an X.on and collect EEG data. And for those of you that are a little bit older like myself, I just want you to pay attention to how quick this happens. So this is it's a recording, someone standing over his shoulder, but most of us know that if you go back to the traditional systems, your setup time is 30 minutes, 45 minutes, then you got to actually do the task. So just get a feel for the timing and the ease of use here, which is pretty amazing to me still. So this is Matt putting on the X.on. Very simple to put on. It's a wet system, since you have to soak the electrodes, ear clip for the ground, and a little bit of adjustment to make sure that the electrodes are hitting where they need to hit. And then you basically open up Peer, and Matt's already into it. He's going to select the X.on as the device. He's connecting to it. And look at that. 30 seconds, you'd call that, and there's EEG data coming in real time into Peer. Now, this is Peer's raw data recording app, but we also can do ERPs. So here's Matt doing an oddball task. If you're not familiar with oddball, I'll talk a bit more about it in a second. Obviously, we did short blocks for the purpose of the demo, and you can export the data in any format you want. It's iOS, so it's easy to share, whether Dropbox, emailed, any of the sharing methods, and data comes out, and boom, you've got an EEG study. It's that simple. So to give you a feel for this, I didn't want to make you watch a 7-minute video, but typically we run a visual oddball paradigm from start to finish in 7 minutes. So that's setup, that's data collection for a proper ERP study, and that is it. So what used to take us 2 hours, you can do in 7 minutes with a mobile technology that you can use anywhere. So let's dive into it a bit deeper. The way Peer ships is, yes, you can collect raw EEG data. All right, that's a standard thing. But what Peer is really about is allowing you to do these ERP paradigms, right? So you can do an ERP task easily, and it comes with a range of games. So I'm going to take you through the paradigms that are within Peer. Obviously, because we just showed it to you, Visual Oddball is one of the games that comes in Peer. We have 3 versions of Visual Oddball. No response version, where you're just watching the stimuli. A single response, where you respond to the target stimuli, and a dual response version, where you're basically classifying the stimuli as the control or the oddball. And again, If you're not familiar with it, oddball is very straightforward. Oddball is basically a series of stimuli, all right? So there is a frequent and there is an infrequent stimuli. So in this case, the target is green. And what happens is you respond to the oddball. So your brain processes that, hey, this is important. You've told me that I should be looking for green circles. And your brain handles that a little bit differently than if it was looking for the control stimuli, which you're basically ignoring. So Peer comes with visual oddball. I'll talk more about customization in a bit, but it's one of the paradigms that's within Peer. And it's not just all about visual oddball, of course. Another paradigm that's possible in Peer is audio oddball. Audio oddball is basically the same as visual oddball. It's just as opposed to a visual stimulus, it's an audio stimulus. Again, there's a no response version where you just listen, a single response version where you respond to the target, and then a dual response version where you're categorizing the stimuli. And again, I'll just let it run for a bit here. I obviously don't want to spend 8 minutes having you watch the full task, but Peer counts you down. There's an instruction screen so the participants know what they're supposed to do, and then it gets going to it. And you can hear the audio stimuli, and that is audio oddball. And when those oddballs happen, that's where you get that different neural response that, you know, is what we study. In case of specifics, a lot of you know that we'd be looking at the M200 and the P300 ERP components typically with oddball tasks. The M200 allows you to get into cognitive control and executive function. The P300 more tied to perception and working memory. And then you can, you know, use these to study what you're interested in studying. As an example of that, currently in my lab, we're using oddball to look at mild cognitive impairment. So we find that people with mild cognitive impairment have a different oddball response than people that don't have mild cognitive impairment. Again, if you're familiar with ERPs, you wouldn't be surprised to know that you can also do go, no, go. Go, no, go is basically the opposite of oddball. It's the easiest way to think of it, which is there is a stimulus that's frequent, which you're going to tap the screen on if it's visual. And then there's an infrequent stimulus, which is no-go. Historically, the reason people get interested in the no-go paradigms is to get into executive function. It does it a bit better than you would if you were just doing a traditional oddball task. But the reality is it's the exact same paradigm. It's just you're responding to the other stimulus. And Peer, of course, can handle the no-go. Now, it looks exactly like an oddball. The key is the instruction set, which is you're going to respond to the frequent stimulus as opposed to the infrequent stimulus. And I'll just give you a short preview. It looks similar to oddball because visually it's the instruction set that matters, but of course Peer supports that and allows you to run the no-go version of the task. And if you're going to have visual go, no-go, you can also have audio go, no-go. So in an audio go, no-go task, it's the same idea. You're responding to the frequent stimuli, and then you're supposed to withhold your response to the infrequent stimuli, and occasionally use luckily one beat this time, but you get the idea again that allows you to do the go, no, go paradigm. Now, if you're familiar with the worlds of EEG and ERPs, there's obviously a lot more to it than just visual oddballs, audio oddballs, visual go, no, go, audio go, no, go. There is NBAC. So if you're not familiar with NBAC is a task that you typically use to get an executive function of working memory. The stimulus set is a series of letters or numbers. Peer handles both. So you can use letter stimuli or number stimuli. It's your choice when you set up your experiment. And the whole idea is to find the NBAC. So in this case, the video you're going to see shows a 2-back, where if the letter sequence is if the A, there's 2 A's that are in a row, but they're separated by 1, hence the NBAC. And then that's what you'd be responding to see that you've, to show that you've seen that. And you can do 1 back, 3 back, 4 back. Generally, it falls apart at 4 back because it's very hard to do, but you'll get a feel for the N back paradigm within peer here. So again, peer always has an instruction screen. It's fully customizable. You can use our default instructions that we provide, or you can write your own to describe the task. And here you'll see FRF and D. So there is the 2 backs happening and another one. And again, these videos are specifically designed to highlight the effect so you can see it, but you get the idea there. In terms of the game itself, I'm going to mention this throughout the rest of my presentation, but peer is entirely customizable. So in the case of the video you just saw, it's providing feedback so you know whether you're right or wrong on the end back. So in that case, the red square was saying, hey, you were supposed to recognize this with a 2 back, but you can turn that on or off. You can set the colors. It's basically, again, the idea with all of these games is that you don't have to do it the way that I designed them, but you can customize them to be done the way that you would like to do them. And it's not just NBAC. A lot of my background work was in reward gambling or the doors task. In a doors task, you basically see 2 doors and you're chasing what I call the reward positivity, but a lot of you might be more familiar with the name of feedback related negativity. And you're looking at the outcome. So there's 2 doors on the screen. You make a choice. It's a gamble, hence the name. And then you find out whether you won or lost money. So you'll see that in the doors task here. And again, with peer, it's customizable. Can't emphasize that enough. Instruction screen that you can put on yourself. Then it goes into the doors task itself. In this case, we're actually using images of doors, but you can use squares or circles. It's really up to you. And you're given a choice. You make a selection. And then you find out whether you won or lost. So in this case, 0 means a loss. You didn't get any money. You make selections and you're gambling. And then there's a win. So you won some money. And the whole point of the doors task is those outcomes, right? So the choice point itself is interesting. The doors, you can look at what's going on in the brain when people are making that decision. But, traditionally you use this kind of paradigm to study the outcome. So feedback processing or reward processing. And for a lot of us, that is interesting because that gets you into the midbrain dopamine system, at least if you believe all the theory behind it. And that allows you to study any number of issues. For instance, right now, my PhD student, Matt, who you saw briefly earlier, is looking at ownership effects using the doors paradigm. People look at it, anything that's addictive gambling issues, ADHD, anything where the midbrain dopamine system might be impacted, you can get at that through the doors paradigm. So again, comes within peer, it's there ready to use. And there's more. Peer comes with the Posner cueing paradigm. I did my postdoctoral work with Dr. Todd Handy, which is where I learned about the Posner paradigm. But in a Posner paradigm, it's basically a visual spatial attention task. So there is a cue that is basically giving you predictive information of where a target might appear. And then the target either appears there or it doesn't. And you can use that to get into the P100 and the N100 ERP components. So if you're interested in visual spatial attention, the Posner task is a great way to study it. And again, I'll show you just a sample of what it looks like in peer. Just so you know, these countdowns actually work in real time. That's just my video editing skills. So it does go 5, 4, 3, 2, 1. But there's the cue. Target could be either side. Target could be that side. Target could be that side. And what you're doing here is you're looking at when you attend to the target and it's valid versus invalid. So that's a valid target. That's an invalid target. That's an invalid target. And you can use that to study the P1 and the N1. And the way it works is pretty straightforward. what happens is the cue sort of gets you to allocate your attention in one direction. And if the target appears there, the P1 and N1 are impacted versus when it appears on the other side of the screen. And again, fully customizable, so you can set up the task the way you want. But if you want to probe visual spatial attention, the Posner paradigm is an excellent way to do that. The last game that's in Peer, at least currently, is called Image Presenter. This is one we designed ourselves. An image presenter is exactly what it sounds like. As a researcher, you can upload 2 categories of images. So, the example I say in here somewhere is you could do cute things versus things that aren't cute. And then you're just looking at the brain's response to the 2 different categories of images. Now, the way Peer's set up, you can actually look at the brain response to individual images as well. But generally, it's 2 categories of images. And I'll show you some data on this later in the talk. But basically, this is just a flexible thing that allows you to sort of do what you want with Peer. So you get your 2 categories of images, you put them in. The images are up to you. You have to decide as a researcher which images you want to use. But then you upload them into Peer, and you can look at the brain's response to these 2 different categories of images. So again, I'll show you a short example of the image presenter running. Again, the customizable instruction screen. Once you're ready, you hit next to count down to the actual task. And you've got your categories of images coming up on the screen. So in this case, we've got cute puppies versus spiders. All right, and the idea here is presumably you have a different emotional response to cute things than things that are scary, like a spider. So I just want to emphasize that the images are up to you. You can up to do 1,000 images per category. There's a ton of customization features, but you get to upload the images you want into Peer. And of course, if this is something that you're just getting into, there's lots of online image sets you could use, which is where I got the spiders and the puppy dogs from. I will note it here just because it's on the screen, is that at the end of it, you're prompted to save the data. Peer will automatically suggest a file name based on the time in the day and the task you're doing. And you can save it, and then you can export. And I'll talk more about the data export functionality in a bit, but everything you need is on your iPad or your iPhone. It's all there. Now, it's not technically an ERP task, but of course, we wanted you to be able to record raw data with Peer. So with Peer as a raw data acquisition screen, it does come with markers, so you can manually send markers by tapping on the iPad. So what we use this for in my lab is steady state data. So eyes open versus eyes closed to study the alpha prominence. But Peer has this as well. And you can, of course, export and analyze. So the display screen in this case is the actual data, so you can eyeball it. And you see the markers at the bottom. It's very straightforward. You hit record, you're recording data. When you're done, you hit stop. And you can go to export. And of course, you don't have to export right away. Most normal iPhones or iPads have quite a bit of memory on them. So you can just save the files. So if you're collecting data, say out in the field, you don't have to export right away. It's just whenever you want to. Of course, if you're in the research business, everyone's always worried about data loss. So we tend to export as soon as we can, but the data is on device as long as you want it to be on device. I will note, because in this day and age we have to talk about data security, the data doesn't go to Apple in any way, shape, size, or form. The EEG data is on device, and then your sharing message, your sharing ability depends on whatever your university's compliance is. So in our case, we just tend to airdrop files to a computer for further analysis. But the data is completely secure and private. All right, for this next bit of the talk, I'm going to take you through some technical details with Peer, just show you a look inside so you can get a feeling for what's happening in the app itself. And probably the biggest thing about Peer is it's customizable. So this is the Peer Studies menu. It shows you the games that are available, and you can create multiple instances of a game. What I mean by that is, imagine you've got 3 graduate students who want to use Oddball slightly differently. Well, you can create 3 different versions of Oddball on Peer. All right, you can create as many as you want in theory. So the idea is that you might have a version that's good for student X and then a version that's good for student Y. And you can set this up so they don't have to change the game. Once you set the game up, it's set up. Now, Peer comes with settings that I've, based on my experience and background, have decided are the default settings, but you can change those. If you disagree with Dr. Olav, you can change your settings to whatever you want them to be, and set up as many different games as you want as well. What's cool about this is you can also share these settings. So you can export the settings as well as the data, so that if you wanted to share it with another researcher, this is how we did Oddball, you just export the Peer settings file, and anyone else that's got Peer can load it and use it as is. So it's a very handy feature to have. Of course, once you're getting going, Peer allows you to check data quality through impedance as per any other EEG system. So here you're seeing the X.on setup, 7 channels that are all green in this case. You can do it by channel. You can look at the impedance values. This is also customizable. All right. So you can dive into Peer and set the impedance levels that you want to maintain in your lab. Again, we've got a default setting that we think is valid given the data, but you can choose the impedance levels you like. And obviously there's a battery there showing you where you're at with your device in terms of your ability to record. So another feature of Peer. This is a shot of what the data looks like after you've done a recording. You can eyeball the data, right? So you can scroll through the EEG data to see what's there. You see the 7 channels of X.on data here. You've got the markers at the bottom of the screen showing you when the events happened. And it's just a chance for you to eyeball your own data at the end. From here, you can choose to export, obviously, as I've said a few times now. But it's just a nice feature that once this is done, you can see the data right away to see whether you're happy with the data quality. Within the games themselves, as I've hinted at, the games are completely customizable. So you're looking at the 2-response oddball screen here. You can set anything you want. The oddball probability, in the 2-response version, there's 2, so there's 2 probabilities that are there. You can set the colors, you can set the background color, you can set the stimulus size. So depending on your device, you can decide whether you want small stimuli. You can set the number of trials, the number of blocks. Peer was designed with researchers in mind. You were able to go in and you were able to set these games up the way you want them. Of course, as I've said a few times now, we have default settings that we recommend based on my experience. But if you don't like the recommendation, you configure the game the way you want the game configured. Here's another screen. This is the gambling task, just to show you some more of the customization. You'll notice the flow at the top, which we call scenes, which is you start with a fixation cross, you have choices, a second fixation, feedback, and then end of block. You can just pick the screen. On this case, we're on the choices screen, so it shows you how many choices are possible. I always use the doors task with 2 choices, but what if you want 6? Well, guess what? You just say 6 choices and Peer will handle that for you. It allows you to shuffle the choices, shuffle the probabilities, randomize them. Again, designed, when we designed Peer, I really sort of said, what are all the possible ways you might want to play these games? And we made sure that those choices were there for you to customize so you could set the games up the way you want. Just a short video here. If you're not familiar with X.on, like I've said, an amazing mobile EEG system, very easy to use and set up, but it does come with the bipolar channel. So if you look at the the electrode at the bottom, that's the bipolar channel. In this case, I've got my PhD student Matthew who's doing muscle contractions with his biceps muscle. So it PEER supports the flexibility of the X.on, which is that bipolar channel you can use as an additional EEG channel if you want to put one in a location that we didn't think of, or you can use it in this case to capture muscle activity or any other input that would come through a bipolar channel. So PEER does support that kind of flexibility as well. Now, the part of I'm excited about the most is the results, and I'm going to spend a fair bit of time taking you through some of the work that's being done with PEER. The first half of this are what I would call validation studies, where we have tried, well, we haven't tried, we have tested all of these games extensively to show that, yes, you can get ERPs with PEER. So let's start with just raw data collection. This is eyes open versus eyes closed. So we tested a bunch of people, and if you, well, again, I'm assuming that most people here have some experience with EEG, but if you don't, when you compare eyes open versus eyes closed, you're looking at the alpha prominence, which you can see very clearly at the back of the head electrodes, P3 and P4. That's the spike at about 10 hertz. All right, which is a classic way to test eyes open versus eyes closed. And yes, you can capture the alpha prominence effect with PEER. Again, not an ERP study traditionally, but just to show you that the raw data capability is there and you can use it to study various cognitive phenomena. Now, when we get into the ERP results, the paradigm we use the most in my lab is the visual oddball paradigm. In this case, this is data from 404 people, and you can clearly see the visual oddball effect, all right, in the data. So it's there and very easy to see. If you do audio go, no go, or sorry, audio oddball, again, you can see the oddball effect very clearly in PEER. So you're measuring high quality ERPs using a mobile system. The reward gambling task, so the doors task that I mentioned earlier, again, within PEER, it's there. And there's your wins versus your losses. And if you're not familiar with this, you're not looking at the big thing at 400 milliseconds. You're looking at about 250 millisecond mark. But there's that little difference between wins and losses. And there is PEER capturing the reward gambling task. This is the NBAC data. This is doing a 1-back versus a 3-back and looking at frontal theta power, so the pooled EEG power on electrodes F3 and F4. And it's a bit hard to see in the FFT power spectra on the left, but when you actually extract theta power, in this case on the lower end, it's closer to it's the 3 to sort of 4 hertz range, you do get this nice NBAC effect where you get much more theta power in a 3-back condition than a 1-back, which is what you would expect. So again, here is the NBAC task. PEER works. Here is some data from the Posner task, so the attentional cueing task that I told you about. If you look at electrodes P3 versus P4, so normally if you're into the Posner world, you're looking at O1 and O2, but just the way the X.on is built, those channels aren't there, so you go as close as you can, which is P3 versus P4. And if you look at your valid versus your invalid cues, you get this attentional effect, which is classic for the Posner paradigm. Now, in this case, I've just picked one of the lateralizations. You get the exact same result, but flipped if you look at the other cue. And image presenter, we put people through our scary versus cute paradigm, and lo and behold, you get a difference at electrode P3. Again, in the theta range for your scary stimuli versus your cute stimuli. And again, it's just showing that PEER does capture data, it does capture ERPs, and it works well. Now, I thought I would, as I head into the home stretch of talking about peer, I thought I would take you through some of the published papers that my lab has done and other labs have done using peer and using X.on. So in a very recent paper, just got accepted before Christmas, this is work by my PhD student, Catherine Bohr, and she's basically looking at the impact of ultramarathon racing. So an ultramarathon, if you're not familiar, is running a marathon, but then you run some more afterwards, hence the name ultramarathon. And Catherine's question was that we know that physiologically, things like an ultramarathon, you're destroyed afterwards. It's a very demanding thing to do. But what about the impact on cognition? So that's what Catherine did. She basically took peer out into the real world. And again, when I talk about mobile EEG, I just want to emphasize just how mobile. So this was data collection done literally in a forest with an X.on and peer. So before the race and after the race, Catherine measured executive function using peer and then looked at the impact of the actual event itself. And lo and behold, guess what? Your ERPs are diminished after an ultramarathon. So it's proof that you can do this in the real world. It's a really cool finding because it shows that there's a cognitive impact to these things beyond the physiological impact. Another thing I want to note here is that given the ease of use of peer in the X.on is the sample size. So this is 76 runners, all right? So when I started doing EEG research a long time ago now, over 20 years, we would have sample sizes of 10 to 15 in our papers. This is Catherine getting data out in the real world where she's able to get data from 76 people, which is pretty impressive. So because the setup time is so fast, because the ease of use factor is so high, you can test large numbers of people. I showed you the oddball data, 404 people. We've tested over 1,000 people now using peer and X.on. So that is another, I call it a strength of mobile EEG, is the fact that you can do these massive data grabs. Here's a different study that we ran. In this case, we had people walking inside versus walking outside. This study was actually inspired by my office at the University of Victoria. We generally have pretty nice weather, rains in the winter, but it doesn't really snow where we are. And I was looking actually out at the gym and watched people walking on treadmills. And I was always going, well, why are people walking on treadmills when they could be walking outside? And is there an advantage to walking outside? Look, this isn't just my opinion. So what we did is we had people go for a 15-minute walk inside or a 15-minute walk outside. And then we just looked at the change in brain function. And what we found, lo and behold, is that walking outside led to a larger P300 response than if you were walking inside. So the take home from that study is pretty straightforward, which is that if you're going to go for a 15-minute walk, good idea, it's good for you, but you're better to do it outside. Again, ease of use. We were testing people literally as they started walking and as they finished walking, and we were moving around our campus to get spots to do this, and you can just go anywhere and do this stuff. Some work again by Catherine, collaborating with a group out of the University of Glasgow, looking at aphantasia. If you're not familiar with aphantasia, it's an interesting thing. I'd actually never heard of it until this paper, but aphantasia is your ability to visualize yourself. So if you close your eyes and you say, if I said to you, imagine yourself collecting EEG data with peer, if you have a crystal clear image in your brain, that's actually quite rare, but you might not be able to do this whatsoever. And what's interesting with aphantasia is how prevalent it is. It's actually very, very common. So in this study, the research group at the University of Glasgow, in collaboration with Catherine, my PhD student, just wanted to look to see if there are EEG differences or ERP differences in people with aphantasia. And lo and behold, there are. People with aphantasia have a reduced P300 response to target stimuli, which, it's the start of gaining some insights as to what's actually happening with aphantasia in terms of the neural differences. Again, more work by Catherine, my PhD student, but she was looking at, again, this endurance activity in the brain. And in this case, it's a 2-hour endurance run as opposed to the ultra marathon. But she was really curious about the time course of the effects. So, what's going on in the brain just after you've done running, a little bit longer and then further out. And what Catherine found is that post-run, there is this increase in delta power in this case, but it's even greater 1 hour after the run. And then at about 5 hours, it starts to come back down. And at 24 hours, you're basically back to normal. But it's just diving into this cool window where you're looking at, well, hey, exercise in the brain, what is the impact? But again, what's cool about this, and I'm sorry, I'm excited because I think this capability is amazing. But the fact that she was able to do this right after people came off the treadmill, like set up time is a couple of minutes and away you go. From a different lab, this is a friend of mine, Corey Coburn at the Louisiana State University. In this case, he was interested in looking at heat stress. So he studies basically firefighters and what happens to heat stress and how it impacts cognitive performance. So in this case, they stress them. They put on their firefighting gear and they basically raise their body temperature and look at the impact on brain performance. And in this case, Corey found these massive effects. So after, pre-heat stress, then post-heat stress is what you're looking at on the left here in terms of delta power. But even 24 hours later, there's still this raised, impact on the brain. So it's a cool result in this space, because if you think about firefighters and what they have to do, this just shows that their brain function is impacted, right? Not just right after, but for a considerable time after. Now, as I head into the wrap up on this, I just want to point out a few things. If you're curious about peer and want to know more, we have a website, peer@eeg.com. On the website, there is tons of stuff. So on the first page, there's a massive piece about peer and how it works, and a lot of the stuff that I've shown you today. If you go to the Paradigms tab of the website, you can get information about the specific games in peer, and all the videos that I showed you are from the website, so you can see peer running. The videos on the website are a bit longer because they show you the actual full game, and I just didn't want to subject you to watching Oddball for 7 minutes while I was speaking. There's the results, so all the data that I've shown you is available on the website. There is a videos page. We've got a YouTube channel for peer, effectively, which has a bunch of videos about how to use peer. So how it works, what the games are, how the settings work, how to export data, basically anything you can want to know. There's a publications tab. So if you want to see some of the work that's been done with peer, we've got links to all of the papers that have been published to date and all of the presentations that people have given at conferences. Because peer isn't just my research group. My research group obviously plays a big role because we're the ones that we developed peer, so we use it a lot because we developed it for a reason. But other researchers are using peer as well, and you can see their work. There's an analysis tab where I provide some tips on how to analyze mobile EEG data. For those of you that are on the technical side of this, there's some things that you can't do with 7 channels, and that you can with 32. Independent component analysis, for instance, doesn't really work with 7 channels of data. But I've got some scripts there in MATLAB using EEG Lab. And I've also got some notes on using Brain Vision Analyzer. Peer data is exportable as a CSV file, and it's very easy to get that into EEG Lab. But you can also export directly in Brain Vision Analyzer format, so you can put your data straight into Analyzer and use that to analyze your data. There's an FAQ where we're answering questions. If we get questions about peer, I think the easiest thing to do is to share those questions with the world. So, because if you're going to ask it, someone else might have already asked it. There is a version history just so you can see the changes that are being made with Peer, and because Peer is a product that, like any other product, grows. And then there's a link to X.on. I haven't talked a lot about X.on in this presentation, but I do want to emphasize and say that currently it is the best mobile EEG system in the world for 7 channels of data. Right, it's an amazing device. So if you haven't tried X.on yet, you should try X.on, because it's, what I tell people all the time is, if you had told me when I finished my PhD back in 2008 that this kind of technology was possible, I wouldn't have believed you. There's no way anyone can build something you can wear around in the world and collect this high quality EEG data. So that's all there on the website. So it's a good reference for you. And just a few more things right here at the end. PureEEG.com, easy to find, and that's the website I just showed you. X.on-EEG.com if you want to see more about the X.on device itself. Plus, there has been a webinar about X.on, which you'll be able to find. If you have questions, please email me. I don't mind at all. It's krigolson@uvic.ca. Happy to answer questions about Peer. If you want to know what it can do, what it can't do, happy to do that. And most importantly, you can get Peer right now. So that QR code will take you straight to the Apple App Store. You can download a copy of Peer. Now, it won't work you need an X.on, so you need to go out and buy an X.on. But if you just want to look at Peer and try the settings, you can actually play all of the games. In a behavioral sense. So you can just try our version of Oddball out and try it for yourself. But you can scan that QR code right now. Peer is there. It's free to download. And like I said, if you do decide to buy Peer and buy an X.on, then there's a process. You can contact Brain Products. But there it is. There's Peer. Anyway, with that, I will stop. I'm happy to field questions. Hopefully we got some. But hopefully you found that interesting, and hopefully you have a better understanding about the Peer software. And literally, it is ERPs anywhere. Thank you.
Okay, thank you for the extensive presentation, Olaf. We have been really flooded by questions, and so I tried to address some of them specifically, but I think that several of them, and we can see like the little reactions. It's actually pretty cool to see them coming in. I have a few questions, and I try to regroup them thematically. So the first thing is data analysis export, and I'm gonna read a few that probably can be addressed together, and then jump to the next one. So the first one is about really exporting raw data. So after having run an ERP paradigm with Peer, can I export the raw EEG data with the markers from Peer? And can Peer data be analyzed in, for example, EEG Lab, M&E Lab, or Analyzer? How would it work? What is the export format? And you covered it partially.
Yeah, so there's 2 principal export formats. The easiest is in Brain Vision Analyzer format. So it comes out with the .EEG file, the .VHDR, and the .VMRK files. So your EEG and markers are available in that format. And if you're in Brain Vision Analyzer format, obviously you can use it with Analyzer. But EEG Lab, for instance, M&E, all of these software types are prepared to receive the Analyzer format. So that is one option. The other option, if you want it in an even simpler format, is you can export a CSV file. So it just comes out as literally the EEG channels and the marker channel and all of the other. You can actually choose whether you want the other things that you can get off of an X.on. So, accelerometer data, things like this. But the CSV format is there. And then on our Peer EEG website, I've actually got a MATLAB script that shows you how to load that into MATLAB to work with EEG Lab. So it includes the locations file, which you need for EEG Lab data. So you've got this one format, which is, the Analyzer format, which is very easy to work with and works with pretty much any software I've ever heard of. But then there's also this simpler format, which is just the CSV file, which allows you to basically, if you want to put it in Python, you can do that. So
basically users are not locked into a specific format, and there is complete data access.
Exactly, because once you get it into EEG Lab, for instance, you can easily transform the format. So EEG Lab allows you to switch from analyzer format to EDF if you want to. So there's one is this sort of sophisticated analysis format, and the other is just a CSV file that you can then choose to do whatever you want with.
Okay, perfect. Okay, questions are still coming in, so I'm kind of like juggling between my notes and the additional questions that are coming in. So other questions are more about the ERP analysis. Some of them are focusing on what is peer doing in the background once the data have been collected, if there is any jitter or delay in the markers, and how noisy, for example, a P300 is at individual levels. How many trials do you usually need?
Okay, to answer the background question, so a big part of developing peer was getting the marker timing in place. So because we're not using an external device, so the traditional setup, what peer does is as the stimuli are drawn or in the case of audio played, it inserts the marker straight into the EEG data stream at the appropriate point in time, which is why you get the clean ERP. So if you go to the peereeg.com website, you get these nice ERP responses because the markers are temporally synced. The resolution is about 2 milliseconds, and that's just tied to the sampling rate of the X.on, right? So the X.on is sampling at 250 or 500 hertz, and that's what gets you there. In terms of, and like I said, the proof is in the pudding, so the data is there. In terms of individual variability, the data coming off of an X.on is comparable to an active champ. So if you actually look at the waveforms and the quality of the data, it's excellent. And so your individual variability is basically the same as what it would be with a traditional EEG system. Now, if you do go to peereeg.com, I didn't show these plots today, but there's actually individual plots, so you can see the histogram, if you will, of the P300 scores from our research. And again, if people have specific questions here, just please email me and I can walk you through the exact numbers and point you at the right things. But the data is the same as our active champ, which is kind of scary, but it is.
Yeah, some people were interested in perhaps seeing like a screenshot of an individual P300 or similar. So probably they can reach out directly to you and perhaps this can be addressed.
The other thing you could do is if you download Peer for free, so if you just take a capture of that QR code, there is actually individual sample data in Peer. So Peer comes with a couple of sample data sets, so you can scroll through them yourself and see what individual data looks like. And if people reach out to me directly, we can't share all of the data we have because of just university ethics issues, but I do have some sample data I could share with people.
Mm-hmm. Okay. Some other questions, more, one on the data analysis. What kind of analysis gives power versus frequency plots? So during your presentation, you were showing some power spectra. Is this done directly in Peer, or this coming from an analysis later on?
No, that's all analysis after the fact. So basically, you can view your raw data in Peer and see it, but then we export. We typically go to Analyzer just because we're familiar with it and we like it. But you can I've done it in the EEG Lab as well. And then the analysis steps are actually on the peereeg.com website. And because of the number of channels, like if people want the crash course, you can re-reference to an average reference if you want to. You can obviously bandpass filter the data. Then we typically segment the data, so we don't do the ICA stuff because you can't. Even functions like EEG Labs, clean raw data don't work that well with 7 channels. But then we just do a simple artifact process using maximum and minimum values. And then we either average for ERPs or we do an FFT. And the nice thing about mobile EEG data is your pre-processing choices are limited just because you just don't have the data to do the more fancy things.
Yeah. Okay, as a quick summary, there are some basic analysis, ERP analysis that Peer is doing on the phone, but the recommendation is to export the data and then crunch them afterwards.
Yeah. So just for visualization purposes, there's a bit of filtering just so that the data is clean, but the actual data that you export is the raw data untouched. So you can do anything you want from there. And
from there, yes, an FFT, frequency analysis, and similar, based on the markers that are generated by the stimulus presentation of Peer eventually.
Exactly. Okay. So the yeah. Peer, just a quick point on the markers. Peer is over-markered in the sense that with all of these games, it's not like if you look at the reward gambling task, it isn't just the markers aren't just there for the outcome. They're there for the doors themselves, the fixation cross. Like in all of these games, there's an array of markers. Again, they're all on the PeerEEG.com website, but you can look at any point within these games that you want to look at because me being me, I just made sure that we put a marker in for literally every single event. So it doesn't matter what it is, there's a marker that you can look at.
Okay, that's covering what I had. Then I have a few other questions on, can you comment on how mobile data compares to stationary data? Why should someone do mobile research? What can you say about the pre-processing of mobile EEG data with few lectures versus a full-blown ICA pipeline or something like that?
So why mobile? At the end of the day, it allows you to do things that you couldn't probably normally do. So I'll give a couple of examples just from my own experience. I collected data on a rock at Everest Base Camp, and there was no way I was going to drag up 2 PCs and a 64-channel system to do that. And probably one it's clinically valid and might be interesting is with our MCI research, we have people that have, they're on the road to dementia, and getting them to come into the lab is challenging. They have to get to campus, they have to figure out how they're going to get there. Then we have to get them into the lab itself. And it limits the people that will show up for that study because some people are just intimidated. They're just like, no, I don't want to go to this busy university and go to a research lab. So what we're doing with X.on and Peer is we're actually going into care homes. So we go to the people that have dementia. We go to their actual where they live and we test them at their bedside. So why mobile is to do those kind of things. So like if you were just interested in basic science on cognitive phenomena, then maybe you do stick with the ActiChamp and you do it at that route. But the range of questions you can ask with mobile EEG is amazing. Like I've tested people, we did baseball players in the dugout before they went up to bat. Catherine's been testing people running all around the world, like, just crazy locations. So why mobile? Because you can get out and ask questions in the real world. And with Peer, you can do it from your iPhone if you want to, from an iPad, and then with the X.on, it's super portable and easy to use. So it is literally ERPs anyway.
Yeah, there are some advantages, some compromises that need to be accepted. It really depends on what's the final goal. Yeah. There are 2 more questions on this experimental design, data export, data crunching. So what paradigms would you use for effective research in Peer? And again, how would you go with analyzing multiple participants with Peer? What do you recommend? And I guess this is connected again to the export.
Yeah. Well, to be fair, it's I guess if you've never done it before, it's not straightforward, but it's pretty straightforward in the sense that, you run the task in Peer. The games are set up with settings that work. But, if you take the oddball paradigm, if you want to do more trials, then you just increase the trial counts. If you want to do less, at some point it breaks because there is a minimum number of trials to get a decent ERP. I'm pretty happy with the 7-minute model, which is 1 minute to set up, 5 minutes to collect data, 1 minute to break down. and that's the default oddball settings that we have, and that's enough to get you a reliable ERP. The beauty of X.on is that the data quality is really high. Like anyone that puts an X.on on will probably be shocked at just how good the data is and how quickly it comes up. And then in terms of the analysis, like I've said, it's actually on the website, but it's pretty straightforward. Like your choices are, your degrees of freedom, to use a stats term, are limited just because you've got 7 channels. So, the question is re-reference or not re-reference. I typically re-reference when we do FFT work. I don't necessarily for ERPs. It just seems to be a better choice. The bandpass filter is what all of us learned in grad school, 0.5 to 30 hertz. But again, you can choose whatever filter range you want. We segment the data to look at the events. We throw out trials that have a massive voltage flux because we can't do the ICA or Newton and Coles to correct for blinks. So we just have to go with the old school approach and throw out, big voltage fluctuations. And then we average, and either we do an FFT and average, or we just average and get the ERP. But the process is fairly straightforward. And again, if people have specific questions, please email me. I'm not upset whatsoever. Krigolson@uvic.ca, and I can tell you exactly what we've done with every published paper. The scripts are on the website. If you want to get more involved, I've got a GitHub page, Krigolson, and I've got all of the processing tools that we use when we go the MATLAB route. But on our lab website, which is krigolsonlab.com, I've also got our analyzer tutorial, because when we use analyzer and how we use it. So it's all there. It's just, it's a big question, right? How do you analyze ERP data?
Yeah, there are several questions coming in about the fundamental natures of ERPs and so on. So for this, I would actually recommend to probably reach out to you directly, because I'm behind the chat, and I think it would would go beyond the scope of this webinar. One question is interesting. Is there something in the pipeline for hyperscanning or recordings from multiple participants with time-locked acquisition from multiple years?
So another reason to go mobile is because of the price point. You can test lots of people. So I can tell you that another one of my PhD students, Jeff Hopkins, is actually going to test 20 people at one time using Peer in a classroom. So it's they're students in a high school. But in terms of syncing the data that way, currently there's nothing like you could do it post hoc, but to do it in real time, it's something that we haven't addressed yet.
Mm-hmm. Okay. Now, going into customization possibilities, these were partially covered throughout your presentation, but perhaps we can go over them one last time. The questions are: can I customize my experiment with my own stimuli? Is it possible to make custom paradigms, for example, for neuromarketing studies with multiple variations of a single stimulus? What are the limitations of visual stimuli on a go-no-go, only shapes, colors, or could it be, for example, short video clips or pictures?
So, 2 pieces to that. Within each of the ERP paradigms, you do have choices on the stimuli, shape, size, color, things like this. But this is where image presenter comes in, because it's sort of a way to design it the way you want to do it. So with image presenter, there's 2 categories of images, but the reality is that you can. The individual images have individual markers. So if you could actually, like just thinking the neuromarketing angle, is you could take your image categories after the fact and then pull that apart, because every single stimuli has its own unique marker. And then within image presenter, of course, you can set the timings and the probabilities and all of these things. So image presenter is kind of our I think that gets the question, which is you can customize it extensively within and just to reiterate, within the individual games, there is room to change the way the stimuli look and things like that. So there's customization there. Again, I would encourage people to download it. Like, it's free, and you can play these games. Like, you could download it right now. You could set up Image Presenter and see what it can do. And then, of course, if there are questions, as ever, email me and I'll give you the answer. Or at some point we will probably release up. Well, we do release updates to Peer, so we can always looking to grow the product as well.
Yeah, I think it's once people start playing around with it, they get even more the gist of it, and it's a really powerful solution. Two more questions to then wrap up. Can I use Peer devices? Can I use Peer with other devices other than X.ons or with other commercial headsets?
Currently, no. Peer is designed to work with X.on, but we are considering other options. So I'd say stay tuned, and we will hopefully support other headsets in the near future.
Okay. One last question: is there an Android app?
There isn't an Android app right now, but it's something that's in the works. So I'd say that Peer, at some point there will be an Android version of Peer. Just the time frame for this is something that we just need to figure out. Okay,
I think we have. Well, we went well over time. I bugged you with questions. I think that it was quite a lot of engagement in the audience. So I really I would like to say thanks to everyone that was actively engaging in this amazing webinar.
Yeah.
Thanks again, Professor Krigolson. We essentially, there is an open line. You can drop us questions either directly at the email addresses the email address that you see on the screen, or on the email addresses that you can find on reproduct.com, should you be interested, or on the websites of X.on, EG.
Yeah.
So we are there for you. Yeah.
And I just say thanks to everyone for showing up and listening. And like I honestly, email me, not offended, and I'll respond as quick as I can.
Okay. Well, thank you very much again. Clap, clap, clap. And well, with this, I will close the curtains. Thank you very much. And
thanks,
have a good day.
Thanks, guys.
Thank you.